Hi. Okay, so we have pressure tested and leak tested the system. I left the unit on pressure overnight at 1700 kPa. It's held the pressure and I'm happy that it's holding. So I'm going to remove the nitrogen and we're going to have to evacuate the system. Evacuate means we use a vacuum pump to remove air and moisture or non-condensables from the unit, from the inside of the system. Moisture in the system will mix with the refrigeration oil, and the oil becomes acidic, and that can cause compressor burnout because acid in the oil will attack the cores in the winding. If you look in a compressor, inside the compressor there's an electrical winding that sits inside the compressor. The oil mixes with the moisture, or the moisture mixes in the oil becomes acidic, the acid will attack the insulation on the copper windings and cause a short circuit and cause a motor burnout, and that will be the end of life of your compressor, which is an expensive repair. So we evacuate the system and remove any moisture and non-condensables. Okay, so before we evacuate, there's a few checks that we need to do. We've got to firstly make sure that the pressure is out of the unit, which we do now. I've got the door open, so there's plenty of ventilation. Okay, but I'm going to close this and explain other things. The vacuum pump. This is a two-stage vacuum pump that can draw a vacuum. Now, before we use the vacuum pump, we need to do a few checks. You firstly do an electrical check. You check the cable. You check the plug. You check the switch on the back. Make sure all that is in order. Make sure there's no frayed cable. Make sure the cord grip is holding the cord in the plug. You check the overall condition, the outside. There's no cracks, it's not broken. You check the oil. That's very important. The oil level has to be on the level line, or almost on the level line, when your vacuum pump is sitting level. The oil must be clean. This oil has just been changed, so I'm leaving it. Preferably after every time you draw a vacuum on a plant, you will change the oil before the next vacuum. Okay? The oil must be clean. If there's any signs of water, moisture, or dirt in the oil, you definitely have to change it, because that's the most important part of the vacuum pump. So once all that is in place, then you take the vacuum pump and you put power onto it and you check that the vacuum pump is working. How do you do that? And you got to check that the vacuum pump is pulling down to a decent vacuum. This is an electronic vacuum gauge that measures the vacuum in the system. Well, basically measures vacuum. Okay, I'm going to connect that on, the power on, and switch the pump on. Switch the vacuum gauge on. Solid connection. And there you can see the gauge goes down. It actually goes down to 170, 160, and still going down. 150 microns. Okay? 150. So this tells you that the vacuum pump can actually cool down to below 500 microns, which is the minimum allowable that it should be cooling down. But obviously, we're right down to 120 microns, so you can switch it off that just tells us that the vacuum pump is working. Okay? With that safe, we are now going to connect after we release the nitrogen from here. Release all the nitrogen. I'm blowing it out the door. Outside, door is wide open. It's blowing out. Remember, ventilation, if you're working with refrigerant, is very important. You also need the safety equipment, fire extinguishers. The escape route must be easily accessible. That's all part of the safety standards. Okay, so there all the nitrogen is out, no pressure. Then only can you connect this to the vacuum pump. Do not connect this to the vacuum pump while there's still pressure in the system. Do not connect a vacuum gauge to a system that has pressure. Okay, before we switch the vacuum pump on, I just want to explain how vacuum removes the moisture. If you know, water boils at 100 degrees Celsius at sea level is because the pressure acting on the water at sea level, which is 100 kPa, will allow the water to boil at 100 degrees Celsius. As you go higher in altitude and the pressure drops, the boiling point of water drops as well. So when you go 1,700 meters above sea level, that's close to Johannesburg, your water will boil at a lower temperature than 100 degrees. It won't boil at 100 degrees. So the same thing happens here. When we draw a vacuum on the system, we are dropping the pressure so low or low enough to actually get the moisture or water that's in the system to start to actually boil and evaporate. It might not sound like it can, but it does. The pressure drops so low that the water will actually boil at normal room temperature without you adding any more heat to it. So the water inside here will start to boil depending on how low you can get your pressure. So we will get into that at a later stage, but just keep that in mind. The lower the pressure, the lower the boiling temperature of your water. So that's what you're doing. When you drop the pressure in the plant, inside the system, you're dropping the pressure so low that whatever moisture and water is inside starts to boil, evaporate, and get sucked out by the vacuum pump. So we're going to put the system on vacuum. Our gauges are still open. The vacuum pump is on and it's sucking. Everything is tight. You also have to connect the gauge to the system to monitor the vacuum. Okay, so I'm going to go and put it on here. And you can see when you leave the gauge on there, it's currently showing atmospheric pressure, but as the pump runs, it's obviously going to remove the moisture, drop the pressure, and then we will get a reading on the gauge to show us how many microns. Ideally, we want a deep vacuum of 500 microns. Now, while we're on the subject of evacuating and vacuuming the system, I also want to tell you about the triple vacuum system, or the triple evacuation process. Triple evacuation process is, you will set up, after your retest, you will draw a vacuum of 5,000 microns in the system. Once you reach 5,000 microns, you will charge 50 kPa of nitrogen into the system. You leave the nitrogen for 15 to 20 minutes, and then you release the nitrogen. You draw a vacuum again to 5,000 microns. You will break the vacuum again with 50 kPa of nitrogen. Leave it for 15 to 20 minutes. Release that nitrogen, and then you will draw a vacuum of 500 microns. So we go into a deep vacuum. The nitrogen helps to break down or release any of the moisture, water particles or bubbles that form inside the system. Nitrogen is a dry gas, so it shakes it up a bit, helps it to get loosened up, and nitrogen also absorbs some of the moisture and will release it when you let new nitrogen go out. So that's a triple evacuation system. But now I'm just going straight into a deep vacuum. So I'm going to run the vacuum pump until I reach 500 microns. Okay, but if I'm vacuuming to get down to 500 microns, then I will break up the nitrogen and put it back into the vacuum. So that's why we draw vacuums underground, and that's a proper way of evacuating the system.